Our primordial Earth had a major difference in its skies we did not realize until now. Standing on Earth almost 4 billion years ago would have been an incredibly hot, desperately lonely, very short existence with there being no oxygen. Now new research suggests that there would have been less lightning around than there is in modern times as well. This could make a difference to any of the hypotheses that suggest lightning may have been involved in sparking the earliest life on our planet. If lightning strikes were actually less common in the early Earth than previously thought, that affects those calculations. To dig deeper, researchers examined how streamers discharge sparks that start lightning may have formed in an atmosphere dense in carbon dioxide and molecular nitrogen, as the atmosphere of the primordial Earth is now thought to have been. Basically, in the nitrogen and carbon-rich atmosphere, you need stronger electric fields for a discharge to initiate. This is what physicist Christopher Kohn from the Tech University of Denmark says. Chain reactions of acceleration and colliding electrons, known as electron avalanches, are crucial to streamer discharges, and how electrons behave changes depends on atmospheric conditions, which is where this newly found discrepancy comes from. To complicate matters, we're not exactly certain what the atmosphere of early Earth was like. Here, the scientists used the carbon dioxide and nitrogen hypothesis, first put forward in the 1990s by geoscientist James Casting. An older proposal from Stanley Miller and Harold Urey, published in the 1950s, suggests that methane and ammonia were actually dominant in the atmosphere during the first billions of years of Earth. It was Miller and Urey who first put forward the idea of lightning forming the building blocks of life on Earth via experiments in gas-filled flasks, but in recent years the thinking over atmospheric composition at the time has begun to shift. Quote, our simulations show that discharges in the Miller-Urey mixture incept at lower fields than in Casting's mixture and partly on modern Earth, which implies that discharges in the atmosphere of ancient Earth might have been more challenging to incept than previously thought. This is what the researchers wrote in their new paper. What all this means is that the process of producing and building up the prebiotic molecules key of life via lightning strikes would have taken longer if recent ideas about the atmosphere of the early Earth are right. The researchers don't specifically quantify how much longer. They only modeled one of the earliest stages in the process of lightning formation, and there remain a lot of unknowns. But they do say the variations could potentially make a big difference in how frequent lightning strikes were. There's lots more work to be done here, such as expanding the scope of the research to include the entirety of the lightning strike process and add in more models of atmospheric chemistry. Ultimately, we're still searching for answers to the biggest questions. If lightning discharges were responsible for the production of prebiotic molecules, it's important to get a very good theoretical understanding of what happened, says Kohn. The big question is still, where do all these prebiotic molecules come from? This was published in Geophysical Research Letters, and it's on Science Alert by David Neal. Let's remember that in the Old Testament we have, before the great flood, Noah's flood, the deluge, we had a difference in the atmosphere of Earth. First of all, we never had rainbows, which means that the intensity of the sun had changed after the flood from what it was before. This is on Science Alert. Please leave your comments, and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support, and that you find all my content so interesting. You'll find the Patreon account details in the description box below.